Good morning. This lesson is for my Trig-Precalc class. This is Chapter 1, Lesson 3. Before I get started, I want to say I hope that everyone's doing okay out there. And let's just go ahead and jump into this lesson. We have 3 goals today. And our first goal is going to be to review slope. Our second goal is going to be to define a difference quotient. And our third goal is going to be to set up the difference quotient. Now, the reason why I'm teaching this lesson now is that essentially you're going to be asked to plug in goofy looking numbers. And so this isn't an extension. The story continues from finding nice ordered pairs. All right. So let's just jump right in. I think this is actually a pretty simple lesson, and you guys should be just fine. All right, so again, let's just review slope. Remember, slope is the equation m equals y2 minus y1 divided by x2 minus x1, and slope tells us how steep a line is. This is a formula that we've seen for many years. I believe you were first introduced in the 7th or 8th grade, so it shouldn't be anything that's too complicated. Now, I'm going to rewrite this formula of slope, and I'm going to change the way that the y's look. All right, I'm not going to say y anymore. I'm going to replace it with its equivalent form and function notation of f of x. So I'm not saying y anymore. I'm saying f of x. Really? Yes. So when I replace the y2 and the y1 with my f of x, remember, in order to get y2, I had to plug in x2, so that's why this is f of x2. In order to get y1, I had to plug in x1, and that's why this is f of x1. All right. So this is going to be our new form for the formula for slope. It's going to look in this form, and I added a picture here to reinforce the fact that x1 and f of x1, those are ordered pairs, as well as x2 and f of x2. Those are also ordered pairs. So when we're using the formula for slope, we're plugging in ordered pairs and we're finding out how steep the line is. And that's what this calculates for us. All right, so this is the version that we're going to be using. Now, I want to point something out about these x values. Okay. I can say x1 and x2, or instead of saying x2, I could say that it's x1 plus some number h that brings me to this horizontal length. So either one of these are the same. Right? We see that they're in different locations, so they can't be equal, so I have to add something to my x value, my first x value, to get to my second x value. So that's why I'm saying it like this. And this allows me now to, again, rewrite my version of slope and start to turn it into the difference quotient, right? So here you saw that I plugged in x2, but I'm not going to plug in x2. I'm going to now plug in x1 plus h, and this allows me to work towards my difference quotient, and this is how we're going to achieve the second goal. So again, I'm not plugging in x2. I'm plugging in x1 plus h, right? And I'm not saying x2 for that value, I'm also saying x1 plus h. So again, I have what appears to be a very, from what we started, a very different looking version of slope, but in fact it's saying the same thing. Now, we can actually simplify the denominator here, and we recognize that these guys are going to cancel out, and I'm now left with just f of x 1 plus h minus f of x over h. This is my difference quotient. This is what I wanted to define. Okay, so difference quotient comes from rewriting slope, and I'm going to check both of those goals off because hopefully I've explained what this is and where it comes from and how we can rewrite it in slightly different ways. Now, our our third goal here is setting up the difference quotient. This is one of those things that it's going to take us a little while to get used to this. So there's certain problems during the school year that I like to just drag along for the whole school year because it just takes a little more time and practice, and we're in a learning environment, and so it's totally fine if it takes us a little longer to get this. I'm not, there's not a, you have more than a day to learn this. Right? I'm going to make sure that you have more than a day, and I'm going to make sure you know how to do this, because this is a very important skill when we get to the next level. So let's start talking about our third goal, setting up the difference quotient. Okay. Now remember, when I use f of x, that's how I define a function. So here I'm saying f of x is equal to 2x. Alright, it could be equal to whatever we want, but I'm going to start off with nice functions, and we're going to get used to plugging in and setting up, and then we'll start to go further with the problem. But again, the last lesson is we were plugging in goofy numbers, and I wanted us to get into this lesson with at least some background in plugging in a goofy number. Alright, so notice that I wrote the same function, but instead of an x, I left empty parentheses. And I'm doing that because I find that if I look at the equation in this form, it helps me to put it into the difference quotient, which is this. Alright, so we're taking this and we're going to replace it with this. So instead of f of empty parentheses, I'm going to say 2 with empty parentheses minus 3. And I'm going to subtract it again from 2 empty parentheses minus 3, and this is over h. Now, I've told you what you're plugging in. I told you right here you're plugging in x1 plus h. And right here I'm telling you you're just plugging in x. So to answer this problem, you write the function with empty parentheses twice, you subtract it from itself, and then you plug in what I tell you to plug in. This is literally us setting up the difference quotient right here. x1 plus h, because that's what I told you to plug into the first one, and the second one I'm telling you to just plug in an x. And this is your answer. That's it. That is your final answer. So this is us setting up the difference quotient. Hopefully it makes sense to you that it comes from the formula for slope. And we're finding the slope using one x value twice and adding adding a number to it to get to our second x value. So I just want you to be able to plug in x1 plus h. Oh, I forgot x1. Oh, it could actually just be x plus h, right? We don't need that x1. Actually, we can do that. It's okay. I better make it consistent. If you have the x1 or if you don't, it's no big deal. But again, I expect to teach this lesson over time, and literally you're just plugging into this formula. Alright, so I hope that makes sense. We'll do a couple problems for the homework. I will talk to you later. Have a good day, everybody. Bye-bye.